Hi, welcome to the lesson on Chapter H7-1, Right Triangle Trigonometry Review. So we're going to start out this chapter by looking at just a review of right triangle trigonometry, what you've done in the past in geometry, so that it is fresh in your minds as we move forward through the chapter. Our objective for today is just to review the sine, cosine, and tangent ratios of angles and sides of a right triangle. Then we're going to look at finding unknown angle measures and side lengths of right triangles using those trigonometric ratios. Let's jump right on in. So what we're going to use here for our right triangle trigonometric ratios is the old acronym SOHCAHTOA. Okay, and we'll talk about what each of the letters means and why it's used here in just a second. You'll see on your diagram here, you've got a right triangle to start out. Our right angle's down here in the bottom right corner. You'll see that we have theta over here. So this is the angle that we're referring to right now. We're going to build our ratios based off of this angle. So if we think about the side that is across from it here, we would consider that to be our opposite side. Okay, this side of the triangle does not form any part of that angle. Okay, the side directly next to it here, or that helps form the right triangle down here, we call this the adjacent side or the adjacent leg. And then obviously the side that is opposite our right angle here in the right triangle there is going to be our hypotenuse. Okay, and so we use those here when we are creating our ratios. So as we talk about it here, we know that, the S in our SO here is referring to the sine function, and the sine is always going to be equal to the ratio of the opposite side over the hypotenuse. So we're just going to go ahead and write there the sine of theta is going to equal the ratio of the opposite side over the hypotenuse. Our cosine, right, this is the part of the CA, or the CAH there, okay, our cosine is always going to equal the ratio of the adjacent side over the hypotenuse. So we have the adjacent side over our hypotenuse. And then obviously last but not least is our T here is for our tangent here. And our tangent is always going to equal the ratio of the opposite side over the adjacent side. Okay, so hopefully you remember that from the past. If not, hopefully that is going to help you. Now we're going to jump right on into some of the problems here and look at how this SOHCAHTOA will help us to solve for missing values. The directions here state, find the missing side length, round answers to the nearest hundredth. We've got this right triangle here, and we're given this 40-degree angle. We have the opposite side here is 18, right? This is our opposite side because we're looking at it in comparison to that 40-degree angle. And then we are trying to figure out what x is going to be. So this x is part of our adjacent side when compared to the angle that's given. So we're going to be looking at, in terms of SOHCAHTOA, right, the one that has the opposite side and the adjacent side in is tangent. So we're going to set this up as the tangent of 40 degrees is going to equal our opposite side, which was 18, over the adjacent side, which is x. Now we need to solve this here. You can do this a couple different ways. If you want to get x out of the denominator, you can multiply both sides by x. I prefer to think of it as a proportion here, and we know with our properties of proportions, we can take this numerator and this denominator and flip-flop them there. It'll give us the same result as if we take it and cross multiply, but this is the same thing as saying x over 1 is equal to 18 divided by the tangent of 40 degrees. So if you want to go ahead and cross multiply, you can, but in the end, you're going to end up with this same statement. So what we need to do right now here is we need to calculate this on our calculator. So we have x is equal to the 18 divided by the tangent of 40 degrees. So I'm going to go out to my graphing calculator. First thing you want to do is you want to check to see if it is in radians or degrees. I want it to be in degrees, so mine is set up correctly. And now we're going to do here, we said that x was going to equal 18 divided by the tangent of 40 degrees. When we hit enter there, we should get 21.451, and I believe we said we wanted to round to the nearest hundredth, so that would be about 21.45. So we'll jump back in here. So x is going to be approximately 21.45, and we'll just call that units since we don't know the length or what units are being used. All right, let's move on to the second one. This one states, find the missing side length again. And again, we're going to round our answers to the nearest hundredth. So we got a little bit different looking triangle here. It's still a right triangle, but we're given this 19-degree angle. We're given a 71-degree angle. And then we're given this side is 27, and this side here is our x that we're trying to find. So this one could be set up in a couple different ways because we have all three angles there. If I were to choose to use, and let's say we're using this 19-degree angle, okay? If I'm using the 19, then this is going to be the opposite side, right, with our 19-degree angle. And this is our hypotenuse up here of our 19-degree angle. Okay, well, the hypotenuse is going to be the hypotenuse regardless, but if I want to do it this way here, I'm looking at, in terms of my SOHCAHTOA, okay, I've got the opposite and the hypotenuse, so I'm thinking about using the sine here. So if I want to set it up to solve this, I'm going to say the sine of 19 degrees is going to equal my opposite side over my hypotenuse. So I have 27 over x. And again, with this one here, we can use our properties of proportions, and we can actually take it and flip-flop our x and our sine of 19 degrees to get x equals 27 divided by the sine of 19 degrees. Or you can go ahead and cross multiply if you want to do it that way. And then we'll just type this in on the calculator to get our answer. So we're going to do 27 divided by the sine of 19 degrees. And our answer ends up being here about 82.93 degrees. I'm sorry, 82.93 units. Since we weren't finding an angle, we're actually finding 82. I think I said 93. We'll double check it real quick. Yes, it's round to the nearest hundredth there. That would be units. Okay, but that's not the only way this one could be done. Let's say, for instance, here you wanted to use the angle that was up here, the 71 degrees. Okay, so if we're thinking about the 71-degree angle, this side over here is the adjacent side of our 71-degree angle, but it's still going to be the, in relationship to the hypotenuse over here. So because we're talking about adjacent and hypotenuse, that means we'd be using the cosine for this one. So we'll go ahead and set that up here. We'll say the cosine of 71 degrees is going to equal our adjacent side over our hypotenuse there. And again, use our properties of proportions. We'll flip-flop our cosine of 71 degrees and our x. And we've got x is going to equal 27 divided by the cosine of 71 degrees. Well, let's just type that in on the calculator here and see what we get there. Whoops, there we go. So we said we're going to do 27 divided by the cosine of, oh, holy cow, I forgot what was it 71 degrees? There we go. And you see there, we get the exact same answer. So it doesn't matter which angle you use as long as you set up everything correctly. So for this one here, we also get 82.93 units there. So it doesn't matter which angle you choose as long as you set it up correctly with the correct ratios. Let's move on. Now we're going to look at a couple here where we're going to be finding the missing angle measure. Still going to round our answers to the nearest hundredth. So we've got our right triangle. We're trying to figure out what theta is going to be. We're looking at our opposite side over here is going to be 34, and our adjacent side right next to us here is going to be 23. So we're going to take this here and we're going to say, opposite over adjacent, we're looking at tangent again, right? So we say our tangent of theta, because we don't know the angle, should equal the opposite side, 34 over 23. And then in order to isolate our theta, our angle here, we're going to have to do, our inverse of our tangent function. So it'll probably end up looking something like this. Right, we're going to do the inverse of our tangent function on the left side and on the right side. So our inverse tangent and our tangent will actually end up canceling each other out, leaving us with just theta on the left side. And then we're going to just end up typing in on our calculator the inverse tangent of 34 divided by 23. Let's go ahead and jump into our calculator and do that. So I have to do second tangent on this calculator here, and I'm going to do 34 divided by 23. And after we hit enter here, we end up with, looks like about 55.92 degrees. So we've got theta was equal to, oh, holy cow, I just forgot what I just said. 55.92, there we go, 55.92 degrees. And that would be our angle measure. All right, let's go on into trying another one here. This one says, find the missing angle measure, round answers to the nearest hundredth. So same thing here, the triangle just looks a little different and we're given a little bit of different information. So we look at this one here, we've got theta is up here. So we've got our adjacent side is going to be 53 and our hypotenuse is going to be 68. So when we're talking about adjacent and hypotenuse there, we're going to be looking at our cosine function. So the cosine of theta is going to equal 53 over 68. Now, if you're more comfortable, if in geometry you went ahead there and you didn't show that you were taking the inverse cosine on each side there and you went more to this, that's okay. I have no problem with that. We're going to say theta equals the inverse cosine of 53 over 68. We'll type that in on the calculator. We'll say inverse cosine of 53 over 68. Hit enter, and it looks like it's about 38.79 degrees. And that would be our missing angle. If you have questions about any of these here, make sure you mark them down and you can bring them in. I'm going to go ahead here and jump on into the next problems. These are applications for right triangle trigonometry. So it says, a kite is flying at an angle of elevation of about 40 degrees. All 80 meters of string have been let out. Ignoring the sag in the string, find the height of the kite to the nearest 10 meters. Always helps to draw a picture with these ones. So remember your angle of elevations where you're taking here, you're starting out looking forward and then you start to look up. So if I look up here this way, that means I'm going to be looking up 40 degrees. This is my angle of elevation. Okay, we're starting on the bottom and then looking up. So as we're looking up there, we're probably going to see our kite that's flying out here, right? Let's just put a little kite on there. Right, woo! Okay, so this string that they have here is reaching all the way up there to our kite. Okay, usually there'll probably be a little sag in it there, but we're not getting that involved in this problem. So it says all 80 meters of string have been let out. So we know that the length from where we're holding the kite down here to the kite is going to be 80 meters. And we want to know there what the height of the kite is to the nearest 10 meters. So our height here is going to be this opposite side. How high in the air is it going to be? So it looks like we're talking about the opposite side and the hypotenuse. So we're going to be talking about our sine function. And we'll set this up as the sine of 40 degrees should equal our opposite side, which is h, over our 80 meters. And now we just need to take it and solve it here for h. Let's go ahead here to isolate it here. Let's multiply both sides times 80. And now we've got here that the height of the kite will be equal to what we get when we type in 80 times the sine of 40 degrees. Let's jump in and do that. 80 times the sine of 40 gives us about 51.42. Okay, so let's just take that and write that down in a second. So I just said it was, holy cow, I said 51.42 meters. Now this is saying that we want to round it to the nearest 10 meters. So if we're asked to round to the nearest 10 meters, that means that this answer here is looking like it's going to be approximately 50 meters in the air. So since they gave us the problem in words, we'll actually answer in words. We'll say the height of the kite is approximately 50 meters in the air. Or above the ground, however you want to write it there. That would be our answer. All right, I got one more here. Let's go ahead and jump on into it here. Another application problem here. It says two buildings on opposite sides of a street are 40 meters apart. From the top of the taller building, which is about 185 meters high, the angle of depression to the top of the shorter building is 13 degrees. It says find the height of the shorter building. So you'll see down here, I've got a little diagram here. This is our taller building right here, you can see. And this is our shorter building, and then this is like our street down in between there. So we know that this building is 185 meters tall. And then if we're standing at the top and we're looking down, remember angle of depression is where you're looking down. You start, level, and then you start looking down. So that is a 13-degree angle to the top of this building. So we're trying to approximate what the height of the shorter building is going to be. How tall is this building going to be? Well, when we look at this here, if we think about if I extended this height all the way from the ground level up to where it was equal to the height of the taller building there, we know that would be 185 meters. Okay, so if we can just figure out here how much taller the taller building is, we can use that then to figure out what our h is going to be. So you'll see here I've got a right triangle already formed. I've got a 13-degree angle. This is my 13-degree angle. I've got here my right angle, and then I'm looking at the opposite side of that 13-degree angle is x. And if you look at the ground, we said that the buildings are 40 meters apart. So that means that they're going to be 40 meters apart on the top too. So we can use our adjacent side and our opposite side to help us figure out our trig ratio. Remember, adjacent side and our opposite side, when we deal with those, we're typically dealing with the TOA part of our SOHCAHTOA. So we're going to say here that the tangent of 13 degrees should equal our opposite side, which is x, over our adjacent side, which is 40. And now to solve it here, we're going to take it here and multiply both sides by 40.
If anybody ordered Chipotle, it was delivered to Mr. Lynch's room. If you could go to Mr. Lynch's room, 259C, and get it. If you ordered Chipotle, please see Mr. Lynch in 259C to claim it. Don't all run.
All right, so I don't know if you heard that announcement there, but the Chipotle was delivered to the wrong room. So back to it here. Let's go ahead and find 40 times our tangent of 13 degrees. 40 times the tangent of 13 degrees is going to give us about 9.23 meters. So jumping back in, we're going to say x is approximately 9.23 meters, which means that our shorter building is going to be about 9.23 meters shorter than the taller one. Oops, 9.23. So if I want to figure out how tall the short one is, okay, we can take this 185 that we had and we're going to subtract the 9.23 meters from it. So as we do that there, let's just go ahead, we'll use a calculator to make sure we're accurate. 185 minus 9.23. It's going to give us 175.77. So that would be 175.7, I think I said 77 meters. And that would be the length of this part of the building, or the height of the shortest building there. Okay, so I don't think they gave us anything to round to on that one, so we'll just go ahead and go with that. So the height of the shorter building is 175.77 meters. And that's it. That would be our answer. So that's the end of the notes for this section. Hopefully this helped you with a little bit of review, getting caught up and feeling comfortable with the right triangle trigonometry. If you have other questions, please make sure you bring them to class. Thanks for watching.